Hey guys, in this video I'm going to show you guys how to write the proof for this statement right here using direct proof. So the first thing you want to do when you are writing a direct proof is you want to turn the statement into its if-then form. So here it says the product of any two odd integers is odd. Well, since there are two odd integers, we're going to introduce two variables. We're going to say if m is an odd integer and n, it could be any letter, a, b, c, d, it doesn't matter. I just like using m and n. So if m is an odd integer and n is an odd integer, then the product of m and n is odd. So then mn is odd. There. Now we can start writing our proof. So the very first sentence you want to write when you're writing a proof is you want to put the word suppose. It doesn't have to be suppose. It could be something else, whatever your professor likes. I just like using suppose because it always works, but writing a proof is an art. So you could use different wordings here and there, but the idea is still the same. So suppose, and then you write the if part of the if-then statement. So suppose m is an odd integer and n is an odd integer. And now we want to address all of the words that are a little technical. So you don't have to write the definition of integer, but you do want to write the definition of odd. So we have the definition of odd right here from the textbook. It says an integer n is odd if and only if n equals twice some integer plus 1. So n is odd when there exists an integer k such that n equals 2k plus 1. So I would want to write something along the lines of, by definition of odd, m equals 2k 1 plus 1 and n equals 2k 2 plus 1, where k1 and k2 are elements of the set of integers. I wrote 1 and 2 here because k1 and k2 are different variables. If I just put 2k plus 1 here and 2k plus 1 here, that means these variables are the same, but they're not the same. So I put the subscript here to distinguish these two variables from each other. Very important. Do not make that mistake on an exam or whenever you're writing a proof. So now you want to introduce mn. So then mn equals m times n. So 2k 1 plus 1 times 2k 2 plus 1. And then now we could just distribute it. So 2k1 times 2k2 is 4k1 times k2 plus 2k1 plus 2k2 plus 1. And that equals, well, you could factor out a 2 right here. So 2 times k, or 2 times 2 times k1 times k2 plus k1 plus k2 plus 1, where 2k1 k2 plus k1 plus k2 is an element of the integers. How do I know that? I know that because integers are closed under multiplication and addition. Here we are multiplying integers together and we're adding integers together. And we indicated that k1 and k2 are integers up here, so that's how we know that. And what does closed under multiplication and addition mean? It means if I multiply integers together, the product is an integer. If I add integers together, the sum is an integer. Remember that integers are not closed under division, meaning if you divide integers together, that does not create integers. Okay, so now I could say let r equal 2k1 times k2 plus k1 plus k2. So m times n equals 2r plus 1, where r is an integer. So all I did was replace 2k1, k2 plus k1 plus k2 with r. So now mn equals 2r plus 1. And this is the definition of odd, right? Which we defined up here. So we could say, which is the definition of odd. Thus, and then we write the then part of the if-then statement, which is, thus, mn is odd. And then you could write a little symbol, this little square right here, to indicate that your proof is done.